Okay, on to the third major area. We really have focused at this point on Lake Marion, the surrounding area of Lake Marion. But we had a number of students in our class that were very interested in the floodplain and the Black Earth Creek and what impacts has that dam really had on that upstream area. We did a lot of historical reviews to understand what that area looked like before the dam was placed there. Then we went out in the field and did some pretty extensive field studies to understand how much sediment had built up behind the dam, how that might have affected the stream quality above the dam, and what would happen once the dam was removed. Because something's going to happen when that dam's removed upstream. And it really presented a number of restoration opportunities for that area also to bring it back to a more natural area. So with that, our floodplain group, Samantha is going to talk about some of the assessment work we've done, and then Lauren will come back and talk about some of the restoration opportunities in that floodplain area.
Hi, so as Joe introduced a little bit, is that when the dam comes out, the relationship between the stream and its floodplain is going to change a lot. So, because what the dam acted to do was to slow the water and cause some sediment to fall out and build up in the stream and on the floodplain, which I'll go into more today. And so what the goal of our project was, the assessment, is to look exactly how much sediment has been built up behind the dam. And the way we did this is we took field surveys along these yellow transects, or to orient you, the dam is located right there and the stream is flowing this way towards the dam. So what we did is upstream of the dam we took field surveys along these yellow transects where we took soil cores to study the thickness of sediment that has been deposited on the floodplain since the dam has been put in place. And those soil cores were taken at these green locations. And with these soil cores, we made a map of the sediment that has been deposited. And the next figure you're going to see is it's a cross-section of the sediment deposited from the dam all the way up to our final transect. So here's the dam, and then this is going upstream, and as you can see, there's a lot of sediment that is built up directly behind the dam. So with our soil cores, we took measurements of several different surfaces. The first one was the land surface, which is represented by this black line. We measured the elevation of that, and then we were also looking for some evidence of the land surface that was there before the dam, which we call the pre-settlement surface. And the way we identified that was by a change in soil characteristics. And below that, we hit a series of gravels like this. And this would have been the old bed of the river from when it would flow along the floodplain there. And so we took all of this information and we entered it into a model where we modeled the three surfaces. So the land surface, the bottom of the old floodplain, as well as the water table, which we were able to get measurements of through our soil cores. And we found that the pre-settlement surface was about 2 to 3 feet above that about 2 to 3 feet of sediment has been deposited on top of that surface that existed before the dam was put in place. And so what this means is that across the entire study area pictured here, if you were going to remove all that, it would be a total of 37,000 cubic meters of sediment that would have to be removed if you wanted to bring the surface down to its original elevation. The goal of this would be to try and reconnect the stream with its floodplain. It would improve habitat along the stream. It would also help with the flow of the stream and reduce flooding, risks of flooding downstream. A big question would probably be, what should I do with this sediment? That's a lot of sediment. there are some good options. You could put it on adjacent farm fields. We tested it. It's quite fertile sediment. The data behind it is in the report. You could also use it as pond fill if you decide to fill the ponds, the small and large ponds. And last, you could sell it off-site if so desired. And now I invite Lauren up.
Back again. Okay, so in addition to assessing the dam's impact on the floodplain, we also wanted to develop some conceptual stream restoration and floodplain restoration options. And so to start this process, we really wanted to examine a more natural reach of Black Earth Creek. And we were able to find a reach just south of our study site, which is right here, just south of Olson Road on the Rentonman's farm property. This is the meander here. And so Sam and I this summer went out, got in our bathing suits, and jumped into the stream with some surveying rods and basically measured the cross sections of the stream. This is at the widest point and see the edges here. But essentially we were trying to understand what the geometric relationships were for the stream profile, the width-to-depth ratios, as well as the relationship between the water surface and the floodplain. We also took a look at the plan and found out what its geometries are, its sinuosity or its meander, as well as channel and valley slope. So going back, a refresher of our study area, this is all on Wolf's property. This orange line is basically the area that we studied that we called the floodplain. You've got Black Earth Creek coming in here naturally and then widening and straightening out as it goes towards the dam, and then it diverts water into the ponds. The yellow lines represent 2-foot contours, and from vegetation and those contours we can kind of see where the abandoned stream channel is going. Lowell had mentioned that before. So taking this existing information and information we got from the reference reach, we're able to develop 2 conceptual options. This first one represents the option that follows the information we found at the reference reach. It's the same gradient, same meandering pattern. So this first reach, we're able to take that pattern to here. However, there's another 3.5-foot drop that we needed to go to, so we had to change to a steeper, less meandering stream pretty much along this stretch between these 2 dots. In addition to looking at the stream plan or its sinuosity, we also wanted to restore wetlands to this area. And in our research of this site, we found from the public land surveys that this actually used to be a marsh. And during our coring this summer in the soil, we actually found this really fibrous soil that's evidence of a buried wetland. In addition to, it's a little bit different, but in addition to restoring the wetlands, you can also create some amphibian ponds, which are those little blue dots in the middle of the floodplain. And this is really a great environment for our little frog and turtle friends, so restoring habitat. And the second option, it's not really that much different. It's just a single but more moderate gradient channel with less meander. In this option, in both options, we recommend, and I'm excited to hear that Lowell and the village is having conversations with the DNR about this, but celebrating the history of the dam by leaving that structure in place, and of course making it a safe place, but also a memorable space to celebrate the history of the dam structure. And also creating connectivity. This would be a hike and bike trail that can connect down to the high school and then up into the Lake Marion Park over here as part of the larger Good Neighbors Trail. And then to step back just a second again, this issue of restoring a floodplain. How do we do this? And so, as Sam was mentioning, we have this wedge effect of sediments that have built up behind the dam. If we divert around the dam, we've got to reconnect those 2 streams. And there's about a 7.5-foot difference between that vertical difference. So that would mean that we'd have to cut through this wedge of sediments, which would look something like this if we didn't remove the soil. This wouldn't be a very well connected relationship between the stream and the floodplain. This is more of the option that we would recommend, creating an elevation of the land surface that has a nice relationship to a flood frequency for a wetland. There are precedents for this in Wisconsin. This is a picture here of the East Branch Pecatonica River. It's near Blue Mounds. A few years ago, it was restored, very similar to our site. It also had about 2 feet of agricultural soil built up on top of it. They were able to scrape that soil, remove it, and then seed the area with a native wet mesic species mix. And this is 4 years later, and it's been quite a successful project. So there are good precedents for this. And then zooming back, looking at the bigger picture, the area that we've just been discussing the past few slides is right here. But there's also the Wolf Run Association that's looking at how this fits into the larger picture of the Black Earth Creek corridor. We know that the Wolf family is interested in dedicating a portion of their property along the creek for stream and wetland restoration, as well as hike and bike trail opportunities and other recreational opportunities such as angling or nature observation, perhaps even canoeing. And then lastly, camping and picnicking opportunities up at Grandma's Park through the Ava Wolf Conservancy. So these are some of the bigger picture ideas. I know Scott Stokes is here. I know he'd be delighted to answer any questions related to their efforts.